Okay, so this is college algebra 4.3, B as in boy, and you got away with a short first video here. My grandkids wanted to go swimming in the lake, so I cut it short so I could go do that with them. So here we are, back to 4.3b, one-to-one functions, and it says, the first sentence, in general, we can show that a function has an inverse if it is a one-to-one function. So we're going to define a one-to-one function as a function f. That's just what we're going to call it. Our function f is one-to-one if each output of the function corresponds to exactly one input. So let's say I have my input there. If it corresponds to exactly one input, then there is a one-to-one function. This means there's a one-to-one correspondence between the elements of the domain and the elements of the range. So again, the outputs are the range, the inputs are the domain. D comes before R, X comes before Y. Okay, so my inputs are X's, my outputs are Y's. Okay, so that gives us a little bit of an idea of what a one-to-one function is. So let's look at example 2 and see if we can make that make a lot more sense than probably what it appears to right now. So we have f of x equals 3x to the fourth power. Okay, so clearly, if we put in a -2 or a 2 in for the x. Okay, so we're going to put those in there for the x. Let's see what we get by putting the -2 in. If my exponent is even, this negative will change to a positive. So I get 2 times 2 is 4, times 2 is 8, times 2 is 16, equals positive 48. All right, let's put this 2 in there. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. I get 2 answers there. Okay, so my input of -2 gave me 48, and my 2 is an input, whoops, let's fix this, also gave me 48. So therefore, it is not a one-to-one function, okay? Because in a one-to-one function, let's see if we can move this up, I could only have -2 goes to 48, and a 2 goes to something else. Okay, in a regular function, this can be true. Okay, but in a one-to-one function, this has to be true. You cannot have two different inputs, two different x values go to the same y value. They have to be completely different. Okay, so that's the difference between a regular function, because a regular function you can do this. But a one-to-one cannot do this. It has to go to exactly one output, or each output has to correspond to exactly one input. All right, so let's look at the B part of example number 2. And it gives me another one. And this time it's f of x equals x cubed minus 1. Okay, so let's see if this is a one-to-one function. So the book makes it a little confusing, I think, to determine if this is one-to-one. They say that suppose we have two numbers. One is A and one is B, but they're not equal to each other. So let's use the numbers 2. That's not equal to -2, is it? Okay, so let's use those. Then this cubed are not equal. And let's try it. Is this a true statement? This is 8, and that is not equal to -8. Okay, so that looks good. Then it says, so if f of x equals x cubed minus 1, then the function of A does not equal the function of B, meaning this does not equal that. Okay, that satisfies what it needs to be 1-to-1. My one value that I plug in for x and my other value are not equal, nor are the outputs equal. So therefore it's 1-to-1. Okay, and remember what we were doing a while back. In order to find out if a function was actually a function, is we would do what was called the vertical line test. Okay, and if it did not cross at more than one point, it was not a function, or if it did not cross at more than one point, then it was a function and everything was great. Well, there's another test out there called the horizontal line test that's done the exact same way, only this time, let's say we have and we do the horizontal line test. The horizontal line test says that a function is 1-to-1 if no horizontal line intersects the graph at more than 1 point. So see here, it intersects it at 2 points. Therefore, this function is not 1-to-1. And how do I know that? Because look what happens here. I put in let's say this number, or let's say that this value here is 3, and this value here is -3. I put -3 in. What does it give me for y? It gives me this point right there. Let's just say it went up 3. So when I put -3 in, I get a 3. What happens when I put this 3 in? I also get 3. So that's the case. Remember what I said? Your y values have to correspond to exactly one x value. Okay? In here I have the same y value, and it corresponds to +3 and to -3. So even though it's still a function, it is not a 1-to-1 function. Whereas if I have a cube function, which is what we have in part B of 277, and it goes like this, and I draw horizontal lines anywhere on here, it only crosses the graph at 1 point, so therefore it is a 1-to-1 function. So, x cubed minus 1, that's a cube function because of the 3. It's going to give me a graph similar to that, and it's a 1-to-1. If I have y equals 3x to the 4th, okay, that gives me kind of a weird shaped, kind of a looking parabola. But I do the horizontal line test. It crosses at 2 points. It is not 1-to-1. So, just something to consider when you're looking at graphs to determine whether it is a 1-to-1 function. Okay, so example 4 is, A, pretty much. We've already gone over that. I'm not sure why they're doing it again. But B says verify that g of x is equal to the cubed root, it's saying that g of x equals the cubed root of x plus 1. I don't like green. It's too light. And they're also saying that possibly the inverse of that is x cubed minus 1. And they want us to verify that that's true. Okay, they're saying it's true. They just want you to prove it. So in order to prove it, what we have to do is we have to, back earlier, there was a little green box on inverse functions, and at the top of this page, there's a little green box that says that. And so in order to verify that, we have to do this composition, and then we have to do this composition. And if they both give us a value of x, then we know that they are inverse functions. So again, we take this one, and we take our g of x, and wherever we see an x, we're going to put that in its place. So that's going to give me the cubed root of x plus 1 cubed minus 1. Okay? And we're going to solve that. All right, and just real quick to solve this, the cubed root of anything cubed is actually everything without the sign. 1 minus 1 is 0, so we just get x there. So we did get an x when we did that top one. All right, let's do the bottom one. Okay, we're going to do it a little bit different. We're going to take our f of x, and wherever we see an x here, we're going to put that in its place. So the cubed root of x cubed minus 1 plus 1, okay, equals, because those cancel, the cubed root of x cubed, which is equal to x again. So there we got it. So therefore it is an inverse. We showed that it was. Okay? Let's go to finding the inverse of a function. We defined it. We got to where we showed what they were. And now we're going to go ahead and find the inverse of a function. They're really, really easy to find. There's some steps at the bottom of page 278, and we are just going to follow those steps. And I'm a step person to where I really like having rules and just give me the steps to do it and I can follow them. So we're supposed to find the inverse of that. First step says rewrite the equation replacing f of x with y. Well, gosh, I can do that. That's pretty easy. That doesn't take rocket science. Step 2, interchange x and y in the equation. Again, not rocket science. Okay, step 3, solve the new equation for y. Okay, a little bit more, but not quite rocket science. So I multiply both sides by 3. I add 1 to both sides. Divide by 2, and I get y equals that. Okay, so that's what it asked me to do, is solve for that. The last step, replace the y, which I have right here, with f of x. So f of x, f, there, inverse, is equal to 3x plus 1 over 2. 4 steps, none of them were that hard, although step 3 is, some basic algebra. But other than that, that's all there is to finding the inverse. Let's do one more here. Still example 5. Well, it says graph it, and then graph its inverse. So pretty much what you're doing is you're just taking this. It's a linear equation. There aren't any exponents on the variables except 1. So we know we're going to get a straight line. But one of the things that you notice about inverses is they are always reflected across this line. This is called the x equals y line, because if x is 2, y is 2. If x is 3, y is 3. Okay, so x equals y, and we get this line that completely cuts this angle here, this 90-degree angle, in half and goes all the way through there. It always reflects across that, or is symmetric with respect to the line x equals y, or y equals x. The book says it's the same thing. Okay, so let's go to example 6, and we'll do that on 4.3c.